Good evening, YouTubes. Got some little 3D printer pens here that I'm going to have a quick look at, give them a bit of a review, talk a little bit about a comparison between them, and then give you a little brief user guide on how to work them. So these have been got for the college students to use. We've given them to have a go with. Some of them got on alright, some of them have been a bit miffed about how you actually manage to print something useful. So I've got an example here on the box. Someone's printed, or this guy's printed a picture or a 3D model of the Eiffel Tower. It's very interesting. I'm not going to claim it is, but it almost looks like that's photoshopped in there. Don't know if you can see that. This lady's finger is just kind of jabbing over here somewhere. Maybe he did 3D print that. But we've struggled to 3D print anything like that. So this one is the 3D stereo drawing pen. It's called the RP100B. 3D stereo pen. There's very little on the box other than that. What does it say? It says that we've got a yellow version, made in China, 16/12/17. So the 17th of December they were making this thing. Wow. Didn't even have a little 2-week break for Christmas there. Maybe it's a bit early to break up for Christmas. What else have we got? We've got abundant material is compatible with intelligent memory. Number 2, high precision of controlling the real-time temperature. Great, I like that. The design of overraised. I don't even know what that word is. Overraised. Individually writing point with quick plumb design. Number 5 is nozzle core with anti-scald design. So I'm going to shove my finger on that and check I don't scald myself. Number 6 is the Intel throat with arc filter. Number 7 is the design of speedy control. Fantastic, don't throw it in the bin. It's got the CE, whatever that means, on there. So that's it really, FCC as well, and Roche. Okay, what have we got on this one? This one we have got, it's the 3D pen. And this one actually has some sort of robot guy here working the 3D pen, and there's like lasers coming out, and there's like smashed crystal, or you know, maybe it's blasting diamond away. I don't know what's happening there. It shows various different colours. It says the world's best 3D pen, just get even better. It does say just get even better. Maybe they do just get even better. Does it say what colour we've got? No, it doesn't say what colour on the box. It's a surprise. What else does it say? They've got that in big writing on the side. Maybe it's my English. Maybe it does make sense. What about on the back? Please read the user manual carefully before using. Our product is beneficial for developing the user's imagination and creativity. Meanwhile, user can enjoy the fun of drawing three-dimensional objects. Magic Brush is no longer a myth. It will come true by using our 3D pen. Portraits, small animals, cartoon characters, everything others you can imagine are all under your drawings and creation. Okay, this is one step closer to make drawings actually come to life and stand before you. That's fair enough. Let's skip that. Oh, hang on. The consumable is biodegradable, PLA. That's good. Low shrinkage, non-toxic, and environmentally friendly. Smells like corn flavour. It's easily to decompose under high temperature. Please use it freely. Okay, we will use it freely. I will ring them up and say I'd like to use some of yours freely. Please send it to me for free. What have we got? A pen, power adapter, user manual, materials. 3D pen weighs 60 grams. Discharging mode, hot melt, extrusion moulding. Forming mode, 3-dimensional shapes. Graffiti range, unlimited. Great. Discharging speed, adjustable, working voltage, 6 volt 2 amps, blah de blah, and all of the usual symbols you'd expect. This one doesn't actually seem to have a model name or number, it's just the world's best 3D pen, just get even better. So that's the one you're looking for, 3D pen. Let's have a little look inside the box and see what we get. So this one, I've opened it briefly. We've got our charger. It says 12 volts 2 amps, this one. So better make sure we don't plug that in there, because I think that one said 5 volts. This one's come with some sample bits of PLA. We've got some nice neon-y green, some nice neon-y yellow in there, and a nice bit of pink that we've had a little test play with. There is a manual. I'll have a quick review of that and let you know any highlights. That's it really in the box. So power adapter, PLA, and the pen itself. Let's have a look inside this box. Oh, similar type of affair, slightly larger box. We've got our 3D Chinese writing, I'm assuming, manual. We've got some, all this stuff's been vacuum packed, some blue, red and green PLA. We have got a 6 volt 2 amp. Now this is a slightly disappointing feature here. I'd have rather that was a USB. That could work, couldn't it, on the 6 volt. Are these the same size port? Yes, they are. So if you're not careful when you've got both of these, it looks like you could plug the 6 volt adapter into the 12 volt unit and vice versa, and quite possibly blow this 3D pen up using the 12 volt supply. I'm not going to test that. I don't know what's inside, whether there's regulators, the heater elements. I don't want to damage it, it's not mine, it's brand new. First of all, I've had a little look at the RP100B's manual. This is this one on this side. There's some interesting pictures here of like a parrot, a rather unusual looking X-wing with wheels on the bottom, and this butterfly that clearly looks like it's just a clip art picture of a butterfly. It doesn't look like a 3D printer pen's ever been anywhere near that. That, again, well, it looks so awful, maybe it has. There's a mask there and some fancy boxes. What does it say? Well, it says thank you for choosing this product. It says there's a filament input hole, the power input hole. It talks about power adjusters here, working LED, the unload button, the load filament button, the speed controller on the side, the heating nozzle. Now I'm pretty sure on the box of this it says something about anti-scald. So what does it say over here? It says warning. This equipment is suitable for children over 8 years old and adult using. Children need to be used under the guardianship of adults. Okay, the nib and its near parts of the equipment is high temperature, dangerous area. The high temperature can reach 230 C. Therefore, no any hand touching or touching other objects by the nib. It is prohibited to use foreign body to insert into the feed hole. Prohibited the use of non-power adapter provided by the company. So that's all pretty bog standard, poorly translated stuff. Oh, there's loads of stuff here about using different materials. I think I'll just say, I think when you turn it on, it's in PLA mode, which heats to about 180 degrees. If you put it into ABS, it heats up to about 230. It does say it does manage ABS. Yeah. It says if you hear crackling, the temperature's too high. Oh, it does only go, according to this document here, up to 210. So if your ABS doesn't melt there, that's that, isn't it? So that's one manual. Okay, the manual here for the 3D pen just gets even better. Is a lot better translated, so it actually reads makes sense. I think it starts with the same instructions as the other one. It says the device is suitable for children above 8 years old and adults. Children should use it under parent supervision. Makes sense. The device, discharging nozzle and surrounding area are high temperature area. The highest temperature of the discharging nozzle is about 200 degrees C. Please don't touch this area or use it to touch other objects. So yeah, apart from the fact I can't read very well, that makes much better sense. Don't put it near water. Don't use filaments from others. Oh, please don't use filaments from others. Oh, it wants you to use its own filaments. So the first thing I noticed with this unit is this unit, which is an improvement, it just gets even better, looks like a more basic version. Okay, we'll have a quick look at the pens. The pen on the left here, the blue one, does have plus and minus. Oh, it has that and that. What does it say the plus and minus do? Discharge speed and the filament feed key. The one on this side actually seems to, I probably shouldn't take that off, but we'll take that off. This one here actually has a digital display, so you can adjust the temperature with a digital display anywhere between 180 I think in the manual to 210. This one, it seems like, only does 200 degrees Celsius. There's no other options. They seem to both have a similar kind of nozzle. This one seems to have a separate shroud here that almost looks like if I squeeze these lugs it might pop out. Yeah, there it is. Oh, we can actually see the heater element right there. So that's the heater element just kind of taped around the nozzle part. There are 1, 2, 3, 4 connections, so I would assume that 2 of those connections is a thermocouple for the temperature, or a little thermistor type sensor, and then you've just got some wound wire around there, probably similar to the type of heater element you'd find in one of those electric cigarettes or something like that. What else have we got? We've got our feed speed, so we can adjust the speed of feed. We have our feed out and our feed in, and temperature settings. This unit, as I mentioned, doesn't have a temperature display. It comes onto a fixed temperature, has a feed out, that one, feed in this one, and the feed speeds. So this one's got a slider, this one's got the speeds. Now I'm not going to look up the prices of these. If you decide to look these up to purchase these yourself, hopefully you'll be able to compare the price difference and go with whichever one you fancy yourself. I haven't tried them both yet, but just erring on the side of the features, this one is much better feature wise. We've got the temperature control here, nice slider. Oh, you've got to love a slider, haven't you? And of course it came with pink filament, whereas this one just came with your kind of drab blue, red, green. This one's got neon, so that's another benefit there. This one, on the other hand, give it its dues, has got the better translated manual. This one, on the other hand, is more entertaining to read. What more can you say about it? I think it's time to plug them in, give them a little bench test. Trying to be very conscious here of the fact that this one's 6 volts only, the other one takes 12 volt supply. I would not want to plug the 12 volt supply in because I reckon there's some electronics in that would get fried. Quite a big difference, double the voltage. So fingers crossed this is the 6 volt, it's on. Let's go to this one, 12 volt, it's on. So what does this one say? It says PLA, this one's just got a blue light. What happens next? It says PLA. What happens if I just press the feed button? So now it looks like it's doing something else. If I click the feed button, this one's now heating up. So it says 30, 32. Wow, that flies away. 50, 60, 70, 80, 90, 100, 120, 130, 40, 50, 60, 70, 80, and we're 190. We're green light, we're going. It's hot enough. What about this one? Is this one hot enough yet? Bearing in mind it's 6 volts, so I'd imagine it would take a little bit longer. Let's see if we can feed. No, nothing. Nothing. This filament that they've sent doesn't even want to seem to slide down that feed hole. So let's have a closer look here. You're going to go in there. Oh, this one's kind of shooting pink stuff out already. It's almost like this PLA with this one doesn't actually fit in the hole. Let me find my trimmer. A bit of an angle on that. It's blue now. Will it feed? Where does it feed from? Oh, so the feed's right at the top. It's literally grabbed that and it's feeding in. Took quite a bit longer to heat up than this one. It also sounds a racket. Still feeding. Is this end hot? Yes, it's hot. Now there comes the green feed. Why hasn't it stopped feeding? Do I need to do something to stop it? It's hot. It is hot. It'll scald my fingers. Another green's coming out of there. Stop. Oh, so I actually manually stopped it by pressing the back button. So I waited for it to heat up, pressed the feed button down, fed the filament in. It doesn't look like it stops automatically. You have to press the back button to stop it. So that one's loaded. Let's have a little listen to this one. You'll hear the motor sounds less clunky, more lively. One thing I notice here is this is actually coming out a lot thinner, a lot more flexible, probably because it's had more heating than the green stuff there. Now this one seems to, if I hold that button, it locks into feeding. If I press it again, it stops and it pulls the feed back a bit. Let's see whether the same thing is true on this one. So I'm going to hold the feed. Sounds like it's struggling a bit, but yes, it has locked. Can I pick the feed up? Yep, so while it's going, I can increase the feed. But it seems to struggle, like it's having trouble pushing this green filament out. And then to stop it, I press the feed button again and it stopped. Just paused recording for a moment. This one over here actually went through some sort of shutdown procedure where it actually withdrew the filament all the way and then seemed to shut down its heater element. So I'll have to let that one warm up again. This one, did that one shut down? It's saying something. Oh, it's gone to sleep. So that one did shut down, but it didn't actually take the filament out. It didn't feed it out. And this one heats up extremely quickly. We're pretty much there. We're done. That one's there, but it did start first. I've got to feed that one back in. It's going to have to feed all the way through. This one is just ready to go by the looks of it. Yeah, there you go, ready to go. So I saw some of the guys today trying to have a go at kind of printing that model there of the Eiffel Tower. And they have seen these videos where they literally start, is that one? Yeah, they just start printing there and just kind of drag the material up and it kind of magically floats in the air. But of course that realistically isn't going to happen, it's just going to fall around. A little bit of a tutorial on how I think that might work. Bear in mind I haven't had a 3D printer pen before, I've just had a couple of goes with one. What I would do is probably start off by drawing these things flat. So let's see if I can print down it. I'm going to do a little pyramid, I reckon. Now, I hope it doesn't stick so well to this card that I'm unable to remove it. Let me see. Oh yeah, it sticks. Sticks to that very well, so I'm not going to get that off there easily. So what we're going to need is some sort of surface that we can squirt this onto but remove it easily. I wonder whether paper would be any easier. Probably not. We'll give that a go. Let's see. It sticks alright to it, but I don't really want it to stick too well. Let that cool down for a minute. Will it lift off there? Yeah, I'd say it kind of lifts off. Still not brilliant. Stuck quite well. So I did find when I did it on the work surface, what's that made out of, mezzanine or something like that, it came off there fairly easily. I'm wondering whether I've got something that might work like I wonder what happens if you try and do it on a piece of alley. Bearing in mind that this alley is going to be cold, so it might not stick well at all, but let's try this. Yep, so that just kind of bounces off the alley, it doesn't want to stick at all. Maybe try with a bit more force. No, it just slides everywhere. So it would seem getting this stuff to stick to a surface might be a little bit tricky, just like it is with a 3D printer. I've got a piece of nice, what should we call this, coffee coloured acrylic sheet there. Why I've got that colour acrylic I don't know, but it's just lying there. So, oh yeah, that sticks. The other one's shutting down, it's had enough. Right, there's a kind of a triangle shape. I'm trying to make some reinforcement in it. Will that peel off there? That's stuck really well by the looks of it. It is peeling off. It sticks quite well, but I managed to peel it off. So what I'm going to do now is make up a couple more of those. Let's see if I can get them any better than that. No. One. I'm going to increase the speed a bit, see how that goes. Seems like slow and steady is better. Okay, so I've got three little, well, four in total, little triangles. Can I lift them off there? One. I think maybe if you took your time with these and built them up a little better, that would improve things. 2, 3, 4 in total. Come on, come up. So it does stick quite well to the acrylic. So my plan is, now that we've got these flat pieces, is to actually knit these together. So we can hear the dogs and the birds outside. It's kind of the first warm day we've had this year, and that's made not just the animals go a bit crazy out there, but everyone's smiling, driving too quick, just because it's about 15 degrees. So yeah, I can just bond these together now. There's one. Let's get another one in there. There is a bit of stringing like you get with a glue gun, but it's nowhere near as bad. This one does quite a good job at retracting the filament. Let's just knit those together. One there. One there. Now, I'm thinking that this device might actually be pretty good for kind of welding 3D printed parts off the 3D printer. So you get your 3D printed parts off your printer in multiple parts, and then you could just use this to actually weld them together. Let's try that in there. And we'll do that one to there. Ouch. Yeah, don't get the fingers in the hot parts, as it said, but looks like that's going to happen from time to time. And then let's actually stick this piece up here. So there we have it. It's my very first 3D printed pen or 3D printer pen part. It's a little pyramid, 4 triangles, welded them together, and that could be the very top piece of the Eiffel Tower maybe. I would have quite a bit more work to do on that to make a complete Eiffel Tower. That'd be quite nice though. So let's see if I can do a similar thing with this one. We've got to heat it up again, it's shut down. It's a nice little feature that they do shut down, which just means that you don't leave them on and they pose a fire risk. Let's heat that one up, it takes a little while, and then I'll just have a go at making exactly the same shape with the other one and see how that goes. Let's shut this one down. How do you shut it down? I don't seem to know the shutdown procedure as such. I might pull the filament out. It seems to get a move on when it wants to. I wonder how the feed mechanism works in there. It must be... Is it a worm? No, it does look like a little wheel that drives. No, it's a little worm. It is a little worm in there. I can see it just spinning around at the top here. So a small little worm. Is this one ready to go? Yes, it is. So what have I got to do now? I've got to do 4 triangles. No, it's stopped now. Why have you stopped? I didn't say stop. I want you to keep going. No, it's not having any of it. It's stopped. Oh. The lights look good. And that's just making a humming noise. That's unfeeding. Let's just break the end of that off in case that was causing some trouble and try and feed that back in. Generally, this one sounds like it's struggling. Doesn't sound very happy. Probably hear that. It throttles up and down in speed. There's various lights that come on and off but don't really describe anything without you reading the manuals, so not easy to pick up and go. Oh, it's started to feed out the end. But it sounds like it's struggling so badly. It is, isn't it? Right, let's see what happens then. No, it literally does not want to feed the filament through. It's its own filament. It's absolutely its own filament, but it's blimmin' hot. The anti-scald system didn't work because I just grabbed the end and it was effing hot. Now the lights are on. Start feeding and it just jams. Let's slow the speed right down. See if that's an issue. No. Just doesn't work basically. I'm going to pull the power lead out of this one in case restarting it helps. I'm going to press that. We've got lights. I might even get the manual out, see what's going on. So we got working indicator is this one, so that one says it's working. This one here says it's speed 2, this one says it's speed 1. What does that mean? You've got 2 speeds, have you, slow and fast? It seems like having the coil on the back is too much for it and it hates it. I'm not very happy with that one. I will have to see if I can coax it into action by feeding this in. Well, it literally just doesn't work, is basically. So I can't get this one to do anything. It's trying to feed. We've got a red light on. They don't even say what the red light means. It's heats to 200. Working indicator, LED speed. Flashing at the same time. Please cut the power. There's no flashing at the same time. There's loads of things about what the LEDs mean. Why I should have to read that, it should be as simple as put the filament in, press the go button, it starts to heat up. Once it's heated up, it should be ready to go. The speed is set to slow. It would make sense that if it was set to high, possibly it's not getting enough heat to the filament and it's blocking up. That's hot. That's very hot to the touch. Is it ready to go? It is, but it can't feed the filament. Start increasing the speed, the light goes red, go down, nothing happens. This one, what a load of rubbish. Let's try this one again. It's gone to sleep. Power it up. Let's try this green filament that this one doesn't want to feed through. Oh, it's very nearly heated up. Perfect. Let's is it actually the filament is come with it doesn't like? Bearing in mind it is the filament supplied. No, this one's taking it in no problem. Can hear the motor is really happy. And we've got lovely green filament coming out the end, so really not sure what's wrong with the blue one. I would say that 6 volts is nowhere near enough to power it. Why they've chosen 6 volts, I don't know. It hasn't got the power to feed its own filament through. It might be that it's not getting hot enough. You can't actually see anything regarding the temperature. Yeah, so this one, good. Little screen on it, temperature control, feed, nice, 12 volts. This one, no temperature control, 3D pens illuminated. Don't know what colours they come in, but this model here, I can't even get it to work straight out of the box. It just jams and complains. So there we go. That's all for now. After a little play, well, you saw the pyramid. I have managed to make a rather messy looking, it's supposed to be a snail, but I only got as far as half the shell. But started to build that up. Not really that impressive. I managed to make a little cylinder that could kind of fit on your finger as a plaster, or maybe extend it up, become something much bigger than that. It's quite strong actually, it feels pretty strong. Could make a bin, or I don't know. Just started off by making a flat square mat and then rolling it up and welding or gluing it together along a seam. And then rather more functionally all made a nice pair of glasses here. So hello possums, that sort of kind of thing. I've got some green spectacles. Will they fold? Yeah, they'll fold, no problem. And a nice red star on there. And again, I did that by producing them as flat parts, peeling them up, and then kind of welding them together. So, not bad for a few minutes. Obviously not going to make any what would you call them, to tolerance engineering components, but for a quick concept model of what something might look like, there's a pretty efficient way of doing things. Much more arty really than engineering based, this kind of design, kind of 3D pen.